Okay, welcome to uh, ARAP week number number 11. So this week, here are the items that we're going to cover. We're going to talk about centroids, do some few work examples, or maybe not. Maybe they'll just talk about examples of centroids, work examples, and we will start our discussion on moment of inertia. We will be using the help of certain videos. So this is what we're looking at. This week's centroids work examples. It doesn't have examples here. So ARAP 124 week 11. So why this is important is because at a certain point, we will no longer have content. So these are the main topics this week. And then the only main topic that will be remaining after we finish this is radius of gyration. But we're gonna leave that till weeks 12 or 13. So you need not worry about it this week, okay? So this is where we are for this week. Okay, this is week 11, and we are working on centroids, radius of gyration, and moments of inertia. So just to recap the memory, so if you have an object and you have a center of mass or you have the center of volume, that would be the centroid. And that is what we can calculate. So I'm going to ask you guys to open up your core shell. Let's see which one are we going to do? Open up your core shell. Go to week 11. Week 11 videos. That's where most of the items for this week are going to be, right? So you've got your checklist as well. You know, you want to review the recorded lecture this week and videos, which is what you're doing right now, and work on assignment number 4. So what I'd like you to do is pause this video right now and watch understanding the area moment of inertia from last week's lecture. Okay, so that's what I'll ask you to do, and then come back once you've watched. Okay, so I'm gonna ask you to pause. I'm gonna ask you to pause right now and then come back. So So now that hopefully you're back, just let's take a look at some of these slides about moment of inertia to again review what we're looking at. Now, a couple of things though, a couple of things. First, there's no integration in this course. There's no calculus. So if there's a mention of calculus or integration, do not stress out. That is not something that you need to work on or focus on right now. Another thing that I wanted to point out is that we will likely be working more or less on axis theorems. Sorry, not the axis, the parallel axis theorem. Okay. Another thing is that you'll probably see shapes like this again and again. The reason is that they're trying to mimic the beams that your structure is is consisting of. Right? So you're going to see us work on problems somewhat like that, or sometimes a little bit different as well. Like, for example, uh, what I want you guys to remember is that the purpose of this course is to help you understand how the calculations are conducted in terms of structures and their loads. Okay, so let's go to the slides and take a look at moments of inertia more closely. So you can see these notes that are posted for you that the moment of inertia or the second moment, and in our case, we're just going to focus on the area moment of inertia, is the resistance and stiffness in a column to a load, right? The term is not really accurate because we're not really looking at mass or inertia, but it's basically the resistance in terms of the I value. So the higher the moment of the inertia, the lower the stresses and deflections for the beams, and the lesser the tendency for buckling, which is what we want to avoid in terms of your structure. Now, the moment of inertia is also considered or a measure of the cross-sectional stiffness. And then there comes another term, elasticity, but that's more of a material stiffness as opposed to the cross-sectional stiffness. So how do you determine the moment of inertia? You are going to be using a reference axis, right? And for us, we're going to be using the parallel uh, axis theorem. And the formula that you want to focus on, more or less, the formula. So if it's around the x-axis, this is going to be the formula, the sum of y squared times the area. If it's the y-axis that you're looking at, it's going to be the sum of x squared times the area, right? Now, do not worry, you're not going to be using integration. Right now, we're just going to stick to the approximate. So I'll put that in writing here as well. We will only stick to the approximate for now. Okay. Maybe I should delete everything so we can. So the most often reference used in our axes are the centroidal x and y axis. And that's why it's important for you to calculate that before you're able to work on calculating the moment of inertia. So the dimensions in case of the moment of inertia is inches to the power 4 or millimeters to the power 4. So please keep that in mind. And what we're trying to do is we're trying to understand how stiff this structure is, and it is measured in inches or millimeters to the power 4. So let's say we have a, a beam like this right here, shown right here. Oops. We've got a beam shown right here, and we know its center of gravity, and we know its height h. We can use x and y axis passing through that. We also know its width b. And what we need to do is we can just use literature to determine what the moment of inertia around the x-axis is going to be based on this formula. So what does this formula basically say? This bh cubed divided by 12. That's what it's going to be for this particular structure. What is b? The width. What is h? The height. So we're not starting from scratch. We're using formulas that are given to us in the engineering manuals. Okay, all right. And let's take a look. So if we've got a 2-inch wide, 6-inch tall joist, what will H be? So let me just go ahead and point that out to you guys. So this will be H, and this will be B, okay? Which is what we use in this formula over here. So for this example, a 2-inch by 6-inch rectangular cross-section, Ix, the moment of inertia around the x-axis can be calculated as bh cubed over 12. It's going to be 2 times 6 cubed over 12, 36 inches to the power 4 for the joist. Let's say we flip it Or we see we're looking at the plank now. In this case, what is what is the height going to be? 2 inches. What is the base B going to be equal to? 6 inches. So just remember that when it says B is referring to the base. H is referring to the height. Okay? Very important that you remember this. And another thing that's important is that there is no calculus. We're just going to use our formula, our summative formula. There's no calculus in this course. Do not stress out. It might be later, I'm not sure, but there's no calculus in this course. Hopefully that is clear to you guys. Okay. So in this case, Ix, the plank is going to be BH cubed. So H is 2 cubed over 12. So it's 4. Hold on. I think this is a typo here. This should be 4 inches because it's what? It's 6 times 8. What's 6 times 8? So 2 times 2 times 2 is 8. 8 times 6 is 48 divided by 4. Yeah, this should be 4. So I think the book makes an error here. It should be 4 inches to the power 4. Okay, so let's just keep that in mind. You don't want to make that mistake. Few of you will get the right answer, but then you have the wrong units. Okay. So as you can see, the rectangle has a stronger axis orientation. Has a strong axis orientation and a weak axis, right? So this is where you see all the typical formulas that you can use to calculate the moment of inertia for different shapes, right? So what I'll do is I'll give you a few moments to take a look. So pause myself. Just take a look at these formulas. And you might want to have access to these formulas while you're solving some of the problems. Okay. All right. Resuming now the slideshow. You can use these calculations for all sorts of construction. And what you do is you do the same thing that we did for centroids. You create a composite. You divide your structure into different shapes. You find the moment of inertia, or use the formulas for moment of inertia for each to determine the overall moment of inertia for a composite shape. We did that for centroids as well, right? And like I said earlier, we use the parallel axis theorem. So the moment of inertia of an area with respect to any axis, not through its centroid, is equal to the moment of inertia of that area with respect to its own parallel centroidal axis, plus the product of the area and the square of the distance between the two axes. So this is what you're going to use, right, in your calculations, this formula right here. So Ix is equal to the sum of Ixc from the centroid plus the sum of ADY squared, where Ix is the moment of inertia of the total cross-section around the major centroidal axis. Ixc is the moment of inertia of the component area around its own centroidal axis. And the area A is the area of the component, and dy is the perpendicular distance between the major centroidal x-axis and the parallel axis that passes through the centroid up. So it might not make sense right now, but it should make sense as we go along in the course. You can do the same formula for Iy, where the Iy is the moment of the inertia around the y-axis. And just flip it over for everything. So, as an example, what we want to do is to first find the centroid of the cross-section. That's the first part. Now, if you don't remember how to do that, let's stop here, and I would urge you to go to this video here, how to find the centroid of a composite shape. Go ahead and watch that video now. Pause this and come back and watch that. Okay, so what I want to do now is to go over a couple of solutions. Towards the end of the class, we'll go over a couple of solutions for how to complete a centroid or to find the centroid. But in the meantime, I want you guys to also use other videos as well that are posted in that same folder, like how do you calculate the centroid. You can stop it, pause it, and resume it. Now, what is the moment of inertia? There's another clip there shared for you guys if you want to look at that as well to help you. Now, what I'd like to do is what I'd like to do now is hold on here. I'd like to take a look at examples. So the reason why I want to go into a few examples for calculating the centroid is that is assignment number 4. So you're going to need to calculate the centroid for assignment number 4. So what we'll do is we'll take a look at a few solutions here. And they are in your folder to find the x and y of the centroid of the shapes given below. So let's say we've got this shape given right here. This shape, right? You can divide it into shapes 1 and 2. Okay? And then what you're going to do is you're going to find the centroid using these two shapes as components. Components 1 and 2. Now you know based on the area of triangles, you can calculate the area as 4.5 for component 1 and 9 for component 2. You've got the height, you've got the base, both. And so you can use that information, and you also know what the x component would be or the y component would be for a triangle. And where are you finding it from? You're finding it from you're using this as your reference origin. Okay? All right. So take a look. So you've got x is going to be 2 for component 1. So it's going to be here, right? 2. And the y component is going to be, it's going to be 1. And in the case of second shape, the x component is going to be all the way from reference to here, but the y is going to be the same. So the y is going to be the same for both. But in this case, it's going to be 2 plus 5. And then all you have to do is you just have to calculate. Use your calculator to calculate, just to fill in the blanks in the table. As you can see here, you add 4.5 with 9, that's 13.5. You add x times the area A for both. So it's 4.5 times 2. This is 9. This is 9 times 5, 45. 54. Then you've got 4.5, which is y times A. That's going to be 4.5 times 1, 9 times 1, 9. So this is going to be 13.5. And you just simply run the calculation. So the x component or the x bar is going to be 4 inches and the y bar 1 inch. So that means that your, I guess your centroid is somewhere, let's see, x bar, y bar. Interesting. It's 4 inches and it's going to be 1 inch for y. So it's probably somewhere over here. It's not here. It's probably over here is where I would put it at. You can actually take a look at the other examples as well. Here you've got component 1 and component 2. And see how these solved examples have filled in the table. Okay. Let's take a look at another example here. So if you've got an L-shaped structure using the reference origin, and in this case, you know what the centroid is because of the shape. It's a lot simpler. So component 1, we'll call this component 1, this one over here. And we'll call this component 2. So for component 1, the area is going to be 6 times 2, that's 12. For component 2, the area is going to be 2 times 8. Actually, hold on, it's going to be 2 times 6, right? So that's the area here. So 2 times 6 is also 12. X for the first component is, we know its centroid is here, so X is going to be here. And in this case, the X is going to be at this distance. So for this, it's going to be 1, and for this, it's going to be, so 6 divided by 2, 3. For Y, it's going to be 2 plus 3, 5. Whereas in this case, it's just going to be the half of 2, so that's going to be 1. And then you plug in the information, and you get the centroid as being 2 and 3. So what would that centroid be? 2, x bar would be 2, y bar would be 3. So x is 2. That's right here, about here somewhere. Okay, so hopefully that makes sense to you. And what you're going to need to do now is solve assignment number 4. So you're going to spend the rest of this time this week going through the notes again and reviewing the assignment solution as well as the centroid example solutions, and then you're going to find the centroid of this. So a hint as how I would do this. I'm going to give you a hint. I would divide this into 3 areas, right? So this is a void. So you're going to, everything you calculate for this area is going to be a negative. So this will be area 1. This will be area 2. This will be area 3. That's how I would solve it, okay? And just to give you a hint, you're going to use the area number 2 as a negative, okay? All right. Don't worry if you're stressed out, just ask me questions if you need to. Now, in the case of the second part, what you're going to do this week is so let me just first post the hint for you guys, so you can even screenshot it. It's in this video. So here is the screenshot, right? You want to use this as a hint to help you solve it. the first one. The second one, if you're unable to solve, well, I'll give you a hint without giving you the screenshot. So for the second one, what I would do is I would split it up into three shapes and then go from there. And I would probably use the centroid at the center. So you can do it one of a few ways, but what I would do is I would use the centroid at the center, the reference at the center. So this is how I would do it. I'll show you guys. Question number two. So it's going to be a bit of a challenge, but you should be able to finish it. So in this case, what I would do is I would use one, hmm, I would use, let's see, this would be number one, number two, and number three. One, two, and three. And I would use this as my reference, right? That would eliminate the whole requirement for the Y bar, right? The Y bar would end up being, or the X would be 0 for each component if you did it that way. So you can do it one of both ways. You can use the reference going through the center, or you can use it from the origin from the side. Okay. All right. So that is the end of my part for this week. So this week there's a lot of work from your end, and I will be back in week 12, and we will continue in the online session on the Monday of week 12. But this week, kind of working on these solutions, you're going to use the information given, and you're going to also use what I've posted for you guys. Don't stress out if you were unable to solve it. Let's see. When is the due date? Let's take a look at the due dates. So the due date for assignment number 4 is the 6th of April. So you do want to make sure that you understand it. And if you have any problems or questions, you want to be in the position to finish it Monday, April the 6th, so you can submit it because it is due that day. Okay. All right. So anyways, that's the end of the lesson for this week. So hopefully you'll have a good week, and we'll be back to normal next week in week 12.